Hello everyone, this is Munir. I'm AI Solutions Architect at NetApp. In this video, I'm going to talk about machine learning version control for data and associated trained models using NetApp Snapshots. I'm going to walk you through a simple MNIST training example and integration of NetApp machine learning version control with the Git repository. As we all know, in machine learning, we perform a lot of experimentation to find the best possible solution for the problem at hand, whether it includes hyperparameter fine-tuning or using different networks. It's important to properly keep track of data used for the particular experiment and the trained models associated with it. Otherwise, it becomes difficult later to link the code used for the training with different configuration and associated with the different data that we use for the training. Likewise, we have a version control for code, like all of us are familiar with the Git repositories, how they manage our code. Like in this, here in this slide, we can see that we have different versions, we have different commit IDs that we can easily use to go back and roll back to the previous state, as well as if we want, we can share our Git repositories with others. But we cannot take this concept and use that for our machine learning examples as well, because in machine learning, we don't only deal with the code, but also associated data, that's training data, as well as the models that we save at the end of training. And these kind of versioning systems are designed to handle code and not large amount of data that we usually use for machine learning and deep learning applications. So traditionally, people copy data and name it accordingly to the state of experiment and push only code to the repository and keep models and associated data used for the training locally. It's a tedious task later to link the code and associated configuration with the data and train models and log files as well. It's very time and space consuming to copy the data, share with our fellow colleagues, and also keep the versioning by ourselves. NetApp snapshots capture the state of the data and at particular time, like we capture the state of code using some code versioning mechanism, as we just saw earlier using GitHub. Snapshots don't use any extra memory. It is just storing the information about the existing state of data. Unlike copying data, it's very fast. It takes usually less than a second to capture a snapshot of petabyte scale data. As a data scientist, we don't need to change existing setup in order to incorporate snapshots for machine learning versioning. With the help of a demo, I'm going to walk you through using snapshots as machine learning version control with GitHub repository. NetApp snapshots by design have support for a CLI, API, as well as graphical user interface, which makes it easy to automate the whole process and integrate with our applications, existing applications as well. Snapshots take care of file ownership as well, so only authorized users can access the data. To better understand the concept of machine learning version control using NetApp snapshots, let me show you how it can be used with our existing Git repositories with the help of small demo. In this demo, we have already created a repository, this one. Here we're going to use one training example where we are loading a training data from the TensorFlow dataset only. And we're using a small, simple model. Finally, we're saving that model in our directory, that is in this case, models, and naming it as train model ts2.5. That means data scientist 2, and the extension is h5 file system. So if we check the repository structure, we have a training script, and we have some configuration scripts as well, and finally a models, where we're storing models. But as we know that we cannot push train models in the repository, so it's gonna be empty just to represent the structure of a project. Let's see on our local repository how it looks. So we already have pulled our code in our local system. So let me check it real quick. So here we have the same structure that we have the Git repository, we have models, we have some configuration files, and at the end of the day, we have training script as well. So let's check the training script, what we have there. So we have a configuration. Let me change it. Let me change optimizer from Adam to RMS prop. We're going to save it, and we're going to quickly start a small training. It's just one epoch, so it's not going to take much time. Okay, so just starting the training. So by the time this training gets finished, we can check our Git repository. Like we have a different commits here. I already pushed some changes in my Git repository. Here you can see we have different commit IDs. If we click on some commit ID, we're going to see what change we did in our repository. Simple. So when we train our models, like in this case, we use RMS prop instead of Adam. And ultimately, we stored our repository, we stored our models in our folders called models. Let's quickly check. And there is our train model named train model ds2.h5. Great. And ultimately, after changing my code, after performing training, I will push it to the Git repository. I'll add all the change to the Git repository, and let's name this commit as changed or using Adam optimizer. Now we will push it to the master branch. Normal git push, nothing special. So here, if we see, we have created a snapshot associated with this training state, like snapshot with ID 0A3D rest is created. So we are here using the git commit ID to link our versioning, to link our models with that particular commit. If we go back in our Git repository, let us quickly refresh it so that we see here the latest commit. And yeah, so we have here the commit ID is, let us quickly have a cross check with what we have here. So commit ID is 0A3D and ends with 805. Here it ends with 805. Also, it created a one directory here that's model.version. If we check it inside model.version, we are having this model here as well. So this is taking the snapshot. This is taking the right current state of a training that we just performed. It's not copying, it's just a point in time capturing of the state. Now, after pushing it, we have here one more repository, like the local repository that is representing, let's say, it can be another user. Here in this case, it's a DS01. Here it was DS02. So we just pushed our change to the Git repository. Let's pull the latest change to our local repository. Before doing so, let's quickly check what we have here in this repository. We just have models. We don't have models version yet that we just created with the help of snapshots. And also, let's quickly check what do we have inside the models directory, because this belongs to other user, other data scientist. So we have here ds1.5. Here we had ds2.h5. Now what we're going to do, we're going to pull the latest version from the Git repository. And we have the latest, we have the recent state restored on our local repository. And model version with commit ID 0A3D and ends with 805 is restored. So we have the same model version state here as well, machine learning, for the machine learning models. Let's quickly check. Let's go back in the main directory. Now here it was not before models.version directory. Let's go inside into models.version directory to see is there latest version of our trained models present. And here we are. So here we are having trained model that was data science 2 ds2.h5 file format that our data scientist 2 just pushed to the Git repository. Going back, if you check the models directory here, where we didn't do anything because it belongs to the data scientist 1, and we don't want to change anything there. So it's going to be having the old model still present there. DS model DS1 that was already present there. If you check here where we did LS before. So it's that easy. So we just push our data and we can share it. Also, if we go back to our Git repository, we can check here commits, go to the commit section. So this is our latest commit. We just changed one configuration, that is optimizer from Adam to RMS prop. And what we have, what we are also having with the help of the snapshots, we're also having the graphical user interface. So let's quickly check that out as well. Let me refresh it. So this is the latest Git commit that we pushed before, and we're having the same commit ID as we have in the Git repository. Let us quickly cross-check it. Let me just check the log. And this one is the latest one, this 0A, starting with 0A, ending with 805. Same here, starting with 0A, ending with 805. So, to conclude this demo video, it's as easy as using normal GitHub. So we just push our code to the Git repository, and with the help of Git hooks, we automate the process of creating snapshots, and we don't have to change our existing code base. It works out of box. Whether you're using some automation tools like Jenkins, you can use CLI, you can use API to integrate with those automation tools that are available in the market. Thank you so much.